type 3 ternary ionic compounds. So far we've looked at binary ionic compounds, which means there are two elements. Looking at type 3 means they're ternary, which means that the compounds are made of 3 or more elements. So far we've only looked at compounds that have one metal and one nonmetal. In order to get a compound that would have 3 or more elements, we use something called polyatomic ions. The term poly means many, and obviously atomic means atoms. So these are many atoms that are looked at as a group. So they are a positively or negatively charged group of atoms. The table you have on the back of your periodic table lists most of the polyatomic ions. So when we look at this a little bit closer, some of these are just regular ions, but most of them are polyatomic. Any of the ones that have a group of atoms, those would be the polyatomics. One example of a polyatomic ion is ammonium. And if you look at your chart here, you'll see that ammonium is right here. And it's in the +1 box. And the formula for ammonium is NH4. So we treat this whole group as one atom, and this whole group has a charge of a +1. Polyatomic ions have a couple of rules that go with them. One is they can be positive or negative. Ammonium you see is positive, but there are others that are negative. Second, the whole group shares the charge, so we don't look at nitrogen and hydrogen individually. We look at this entire group to see that the whole group has a charge of +1. This whole group you're going to treat as if it's one atom. So you treat the NH4 the same as you would just treat a nitride, which would be an N. And the last rule would be when you need more than one in a compound, you would use parentheses. So for example, if I were going to say that I need 2 NH4s, I would put NH4, parentheses, and then put the 2 on the outside. So these are the basic rules of the polyatomic ions, which lead us to our ternary ionic compounds. So we're going to start with naming the type 3 ionic compounds, and we'll jump right in with an example. You'll need your periodic table and your table of your ions. So if we look at this, I have Al2SO4 3. So we want to name this compound. So the first thing we do is we name our metal. So when I name the metal, I look at the first element, which is our positively charged element, atom, and I can see that it's Al. When I look up Al, it's over here. If I don't know it off the top of my head, I find out that it's aluminum. So I would write aluminum. My next step is I want to name the nonmetal, which is our negatively charged particle. And what I have here is I see the parentheses, so I'm looking for this whole piece. So if we look at our polyatomic ion chart, I'm looking for SO4, which I find right here, which is sulfate. So I've named the metal and I've named the nonmetal. The next thing I need to do is just check real quick if my metal is a transition metal. So when I look at aluminum, I see that aluminum's in group 13. It is not in the transition metals section, so the answer for this would be no. So all I would do then is just name the metal and the nonmetal. So this compound would be named aluminum sulfate. You notice there is no Roman numeral because aluminum is not a transition metal. For our second example, we have FeOH3. So we're going to start this the exact same way. The first thing I'm going to do is name the metal. The metal is Fe. That is iron. And And OH, it has parentheses, so that right there is going to be a hint that I'm going to need my chart. So I'm going to use my chart here, and I'm going to try to find the OH. When I find OH, I realize that my OH is right here, and that is hydroxide. Then my last question is the metal a transition metal? So when I look at iron, I see that iron is a transition metal. So that means I add one more step. So because I answered yes, I need a Roman numeral. Now here is the tricky part because I need to figure out what Roman numeral I need. So I have to look at the charges of each one of these. I need to figure out the charge of iron. So that means I need to look at my hydroxide. So OH has a -1 charge. That's right there. And up here it tells me that I have 3 of them. So I have an OH negative, an OH negative. And I'm going to just put these in parentheses so that they're all grouped together. So I have 3 negatives here. But when I look at my Fe up here, I don't have a number there, which means I only have 1. So in order to counteract these 3 negatives, I need 3 positives, which means that my Fe has a +3 charge. So if I have a +3 charge, that becomes my Roman numeral. So I put my Roman numeral in parentheses. So to name this compound, I would name it iron 3 hydroxide. Okay, so let's move on to writing the formulas when you have the names. So our first example is going to be barium sulfate. First, I want to find the metal and its charge. So I know that the metal is my first element, which is barium. Barium is found right here in the periodic table. It is in column 2, so it has a +2 charge. So I would write Ba with my +2 charge. Next, I want to find my non-metal charge. So the first thing I'm going to do is look at the ending, and you can see that it ends in -ate and not IDE. So because it's not ending in "ide," it's ending in something different. It's probably going to be a polyatomic ion, so I need to look at my ion chart. So I'm going to look for sulfate on my chart. So I'm going to find it right there, and I can see that it has a -2 charge, so I'm going to write that as my SO4. So I have to leave the group together, and the entire group has a -2 charge. Now that I have my metal charge and my non-metal charge, I can balance out my charges in order to write the formula. So I'm just going to write out all of the pluses. So I have barium that has a +2 charge. I have SO4, which has a -2 charge. So I have 2 pluses, 2 minuses. Everything's balanced. So I don't need to add any more. So I would just write BaSO4. You notice that I have a capital O here because it is talking about an oxygen. A small o would mean something else. So my formula would end up being BaSO4. Let's do one more. So I want to write the formula for nickel 2 acetate. So again, the first thing I have to do is find the metal charge. This one has a Roman numeral, so it's pretty easy to find the charge. I just need the formula for nickel. So that's Ni, so I write Ni, and because it has a 2 here, I know that this has a +2. Then I look for my non-metal charge. Again, this does not end in IDE. It ends in the 8, so that means it's going to probably be on my polyatomic chart, so I'm going to locate acetate. It's right here. It has a -1 charge. You notice this is kind of a longer formula, so it's C2H3O2. This whole group has a -1 charge. I'm just writing the parentheses so you can see that it's grouped together. So now we need to balance it and write the formula. So I have my nickel, and I have 2 positives, and then I have this whole group for acetate, which is only a -1. So if I look at my positive and my negatives, you can see they are not equal. So I need another negative. So that means I need a whole other acetate ion with a negative. So now when I look at this, I have 2 negatives and I have 2 positives. So now I can write my formula. So how many nickels do I have? Well, this whole piece right here, this whole ion is 1, so I have Ni. And then I have 2 acetate ions. So I'm going to need parentheses. So I have C2H3O2, that's acetate, and I have 2 of them. So this 2 is talking about how many I have. So the formula for nickel 2 acetate would be this, which is NiC2H3O2 2. Let me know if you have any questions.